Warm welcome to you, Danny. Danny has an impressive background, having worked with machine learning, AI for a number of years, leading very interesting companies in this space, Microsoft, IBM, Uber, and now Unity Technologies. So I suggest we start this off, Danny, if that's okay with you, maybe just giving a brief introduction about yourself. Yeah. So warm welcome to you.
Thank you for having me. Let me just get into my background quickly, because it's sort of going to give you a good impression of you know how I have used machine learning and AI in various enterprises. And at Unity we really have AI and machine learning playing a strong role in monetization on the ads side. It's in the analytics for game developers, so they can build better games by basically getting feedback from their users. And it's in automation of elements of game development, which we can talk a bit about later. And then essentially on the what we call sort of the industrial side, the industrial use of Unity, which you can also talk a bit about later. Before joining Unity, I was head of machine learning at Uber. The idea at Uber was essentially to create a machine learning platform. Mm-hmm. And we're going to talk a bit about machine learning and AI, how it relates. Yeah, but it's a machine learning platform that was company-wide. And the idea was that if you really get machine learning into every corner of the company as a whole become a more intelligent entity and will run the business in a smarter way. Yeah. So at Uber we basically looked at machine learning in three large areas of the company. It was the core business, which is drivers, riders, and trips, to optimize that. Then there was the whole mapping business, which is creating maps for the Uber drivers, which used a lot of computer vision, a lot of other kinds of machine learning to automate the creation of those maps. And then, of course, there's the self-driving cars, which really use a lot of machine learning to get that going. But the point is that it was the same machine learning platform across all three parts of the company. Before that, I was general manager for machine learning at Amazon. It's kind of the same story. I was creating what we call the elastic machine learning platform that ran across the company. It was used by over 100 teams across Amazon for everything from predicting shoe sizes of customers to allocating robots in the fulfillment centers. That service was so popular within Amazon that we have also built a public version of it and launched that on Amazon Web Services, mm-hmm. where anyone can go and use it for a fee. And before that, I ran a machine learning toolkit team at Microsoft. I did 2 startups and worked at IBM Research and started at Brilliant Care.
So you have a
yes.
You actually worked in Denmark.
I
also.
worked in Denmark in Brilliant Care for several years.
Okay, very interesting.
But the point here is that it doesn't, whether it's Amazon, Uber, Unity, mm-hmm. a lot of these technologies are really the same.
Yeah. And then, so from an educational point of view, you have a PhD, right?
Yeah.
And are you from the math side, or are you computer science?
Computer science.
Computer science.
Computer science.
All right. Super interesting and just super very impressive. But let's try to take this down a notch, because I think most people have heard about AI, and they might also have heard about machine learning. There are a number of concepts that kind of are out there, and I think many people have a hard time understanding. I think the concept of AI maybe, but what is it actually? AI, machine learning. What are we talking about?
Yeah. There seems to be many definitions floating around.
Yeah.
The way I look at AI is that AI is the expression of some underlying technology that make a system exhibit some smart behavior.
Okay.
Yeah. So AI to me is something that is really on the surface.
Yeah.
Underlying is really a paradigm shift, and that is machine learning. And the most important part with that is that we are today in a position to move through a paradigm shift from programming a computer mm-hmm. to training a computer to do things for us.
Okay. Yeah.
And there are many examples where we traditionally would program the computer through a deep understanding of the problem domain. Yeah? We'll do all these requirements analysis, and we do the design, do the implementation, we'll optimize the implementation. But there's a dramatic shift away from that, where we basically take the data, show the data, and teach the computer by example to do the job. And then what we utilize there is machine learning, and that is really, in fact, a, should we say, limited set of learning algorithms.
Right.
So it's actually not about the algorithms as much as about the data that we use to train the computer.
So just within the realm of machine learning, deep learning, what are the concepts there?
Yeah.
Because machine learning, as I know, I think I even heard about it when I studied, took some computer science courses back in Copenhagen. So it's been around for a while, hasn't it?
Yeah. So what we talk about is traditional machine learning has been around for a while.
Yeah.
And it has become more and more popular with increasing computing power, increasing amounts of data. We've been able to use it more efficiently. It has a basis in statistics, applied math. What has happened over the last, should we say 6 years, 5-6 years, is that deep learning have become very popular.
Yeah.
And I started in deep learning back in 2011, and we very quickly saw some incredible results. I have come to the conviction today that deep learning is here to stay. It's just basically beating all existing approaches in most areas. At Unity, we are totally based on deep learning now.
It seems that there has been a shift over, actually very recently, over the past years. You're at 2011, 6 years, but even in the last couple of years, it seems that it has become more accessible to more companies to work with machine learning and use AI.
Yeah. So it's really two things. Number one, just as I made a machine learning system available on Amazon Web Services, that was a traditional machine learning system that allows a wide range of companies to certainly use this technology at scale. Deep learning has gone through a revolution over the last even just 2-3 years. But overall, it's the computing power that is changing the game. It is that we can have teraflops in small servers now. We couldn't do that 10 years ago.
No.
10 years ago is also actually when the iPhone came out. And it's only over the last 10 years that we have gotten used to have these very large amounts of data from consumer applications.
It's really changing. It seems to be quite intense here in Silicon Valley, what's happening in this space. Just as an example, this morning driving in to our meeting here, I was listening to NPR, and there was a conversation between President Obama and President Trump. And it was based on synthetic voice, meaning that there's a Canadian company with 1 minute of recording of voices that can synthesize voices. It wasn't perfect, but it was pretty damn scary because it actually did sound like a conversation between two persons who'd never talked like that. It was not the usual type of conversation between presidents.
This is a concept that is fairly new. And it's basically based on deep learning.
Okay.
Where you teach a neural network in a person's voice. And then you basically use that network sort of in a reverse way to generate that voice from text. And the interesting element there is that this is a technique that is 2 to 3 years old. You can use it to generate voice. You can use it to change styles in images, so that you can train a net on Picasso, and then all your images that you feed through that net will look like they were painted by Picasso. They will adopt the style. These are called generative nets. And this is, by the way, something we're very interested in at Unity, because it allows us to generate texture in surfaces that look very natural, but they're actually using machine learning to generate. There's complete new usage of it. Yes, it's every day.
Yeah. I'd like us to move into, let's say, the business side of it, but I can't help it. Before we do that, let's just talk about the kind of the big worries about machine learning, because I'm just thinking about a conversation again between Trump and Obama. I'm thinking fake news, all the things that can happen in a society. 2013 crash where somebody hacked AP's Twitter account and it sent all the trading. I don't know if it's algorithmic or machine learning based, but it's kind of in this space here. It sends stocks down. So are we moving into a better world, or are we moving? Where are we going with all this? Because it seems pretty scary. What's ahead?
I don't want to get into better or worse. I think we're gonna go into a different world.
Okay.
And it's gonna be different in the sense that we're gonna train systems to take action for us.
Yeah.
And we will have to focus more on how to train these systems rather than program them.
Yes.
When we program them, we kind of put up all the boundaries for the system, But when we start training them, what we want to achieve with that is that if the system meet or encounter a novel situation, it will do something reasonable based on that training.
Yeah.
However, we don't really know exactly what it's going to do. I worked on self-driving cars. Everybody asked me, if there's a child and an adult and a vehicle, what is it going to do? Is it going to, kill the driver rather than killing the child on the sidewalk and things like that? And it's like, that's really, really complicated because we actually don't know.
No.
Because we'll train the car to avoid killing people in general, and it will make some decisions that we may not fully understand.
No. So we're moving into, as you say, a different world.
A different
world.
Hard
to put values on it.
Yeah, and I think a lot of future science will be based on what we call learning theory, basically going back and study how school works for computers.
Actually, we do have a question here. Brian from the company SubHub, he's asking, do you have any thoughts about requiring machine learning to prove how it has reached a decision? So an insurance AI can tell you why it rejected an applicant.
This is a big challenge. In traditional machine learning, which is based on statistics and applied math, we can, in most cases, actually understand how it got to a given decision. It's pretty known, both science and technology. When we're moving into deep learning, it gets more complicated. A lot of the magic in deep learning is that it is a black box. And often we do not know why it's making the decision it's making. For legal reasons, especially in EU, you have to explain why you're rejecting a loan. It's something that we're going to have to work on.
And when you distinguish between traditional machine learning and deep learning, is that because it's more rule-based in machine learning, so you can find out which rules kind of triggered the decision?
Yeah, you can decide. So what we do in traditional machine learning, we know the features that we feed into the system. Think about a nice Excel spreadsheet. We know exactly what columns we feed in. And we know the importance of those different columns. So if income turns out to be, the determining factor, we can state that. We can see that very, very clearly. When you move to deep learning, what we do is that we don't feed in those columns any longer. We actually feed in a much richer data set and let the system, it may include your CV or your resume, it may include a lot of your history, and we feed that in, and what deep learning does is that it does what the data scientist normally does, which is figuring out what is important, what matters, what does not matter. But that happens inside a neural net. And today, you can't look at that and make sense of it. The only thing we know is that the output is of high quality. Whether that is approving loans, assessing credit ratings, or driving a vehicle. It works really, really well. Works actually better, in most cases, much better than traditional learning.
You've been using some videos
Yeah.
And I'm thinking maybe I would just give you a few minutes just to
Yeah.
explain this learning process.
Yeah, I have a video that may explain this really well.
Yeah.
So this one is interesting, and this is to me the important part of AI
Right.
and machine learning as we
Yes.
see it today, because what this is an example of is we're trying to teach the chicken here to cross the road, and we have a completely generic learning algorithm.
Right.
And we call this reinforcement learning.
Yes.
Yeah? So I'm not even feeding it, I'm not giving it any data ahead
No.
of time. I'm basically telling the chicken you can go left, right, forward, backward. Yeah.
Yeah.
And the rewards I give the chicken is basically that it's a penalty for standing still, it's a penalty for moving, and then it's a penalty for getting hit by a car,
Yeah.
and it's a positive reward whenever it picks up a gift package. Yeah.
Mm-hmm.
And it will start out in an explorative mode
Yeah.
because the algorithm actually doesn't even know the game.
No.
Yeah.
So it's completely generic.
Completely generic.
So it's not made for this game at all.
It's not made for this game. Even more crazy
Yeah.
is that we actually use deep learning here is actually just looking at the pixels.
Yeah.
It's not even getting the game state. So it's
Okay.
actually seeing
Right.
what you're seeing literally
Okay.
in pixels.
Yeah.
Yeah?
Okay.
So it's viewing the game,
Yeah.
and it's getting basically the only information it gets back is whether the chicken is hit
Yeah.
or whether it gets a gift package.
Okay.
Yeah? And you can see this this video, and initially the chicken is just randomly moving around.
Mm-hmm.
Yeah. What it's learning at this point is that they got a gift package.
Yeah.
So it picked up a little piece of information
Yeah.
there, and now the chicken, after an hour of training, the chicken can pick up a lot of gift packets. It does get run over by the trucks once in a while here, but the point is that
Yeah.
there's no programmer,
No.
there's no designer here telling the chicken how to operate.
No.
Yeah. So after 6 hours, it gets really good at this. Yeah. It will not get run over. Those cars are coming in randomly. The exact configuration of those cars is normal all the time,
Right.
because it's so random.
Yeah.
Yet it can deal with it.
Right.
This could be a loan agent.
Yeah.
This could be a funds manager. They just get better and
Yeah.
better and better.
Yeah.
So this is a total paradigm shift. Yeah.
It is.
It's not even gathering a lot of data and then, train the system.
No.
It's just training on the job.
It's learning by
By doing.
By doing.
Yeah.
It could be a loan agent. So you're saying that you could have this generic algorithm learning from looking at loan applications and testing to give them the loan or not.
Yeah.
And if there is a reward by giving the right applicant the loan,
Yeah.
then it's going to learn
Yeah.
to do that again. If
Yeah.
it rejects the right ones, and over time,
It will hone in
yeah, yeah.
on the right set of
Yeah,
choices.
and that would be the training you would do based on historical data.
Easy with the chicken here because it gets run over by the truck, but it respawns again. Yeah?
Yeah.
In real life, we have to bootstrap.
Yeah,
So we either have to take historic data, or we basically simulate
yeah,
to get to a level where the loan agent functions
Right.
well. But then going forward, every single customer interaction
right.
and every single experience gained
Yeah.
feeds back into the system and makes it better. And that's real AI.
Yeah,
Yeah, that's real AI. Yeah,
Yes.
because now the intelligence get built into the system, and there's no human intervention in that loop.
no.
Yeah.
I know you have another example of this woman doing gymnastics, I
Yeah.
think.
Yeah.
And is that the same algorithm? Or
It's the same algorithm.
Okay.
It's the exact same
Okay.
algorithm
Right.
of the character doing the swinging,
Okay,
which is fascinating.
it is. Yeah,
Yes.
yeah,
Where in this case we have 4 movements for the chicken. What we see here is we have 7 actions, 7 movements she can do, to learn to swing.
yeah.
So again, there's not a game developer here.
No,
It's basically the system looking to maximize the reward, And we see that it gets very natural.
Yeah.
The swinging gets very natural. This is how a kid will learn to swing. Yeah.
Yeah.
And my point is that it's the same algorithm.
Right.
Yeah. In this case, after 5 hours, she gets really good at it. Yeah.
Right.
Yeah.
So, and this again, it's a generic algorithm, and so it can be used for many games,
Yep.
many applications,
Not-
and it doesn't really require the code development because it's already built.
And it improves itself, its own performance. So this is the same technology that will be used to making movie recommendations, book recommendation or product recommendations on Amazon. It's the same. It's basically the reward here is that you make a purchase. So it will run on millions of customers and trying to improve the sales.
Right.
Click-throughs on pages when people come to the bank or financial institution looking at products, what they click on, what they don't click on. What you learn is what is important to the customer.
Casper Rost asking, wouldn't you solve the documentation in deep learning with implementing forward changing, backward changing? This is a technology that documents all outcomes, conclusions. A bit technical to me, but I'm sure you know what Casper is referring to.
Yeah, I do. And without going into deep detail, I can say two things. Number one, this is a very active area of research, but it's really, really needed.
Yes.
Number two, that there are various methods. I talked a bit about the generative nets, which is where you start using the net the other way around, which means that you can explore what are a set of likely inputs to give, for instance, to approve a loan application.
Right.
And there you can generate a number of scenarios, and you can start analyzing those scenarios systematically, and a large amount of them, and determine whether is there anything in those decisions being made that may be based on ethnicity or other things that you should not really take into account. Let's
move into a little bit about the business. Because we've kind of touched upon it, because ultimately it's a new tool for business, and what type of applications? I mean, we kind of touched on it. Where do you see where is it that in your experience that your AI has really made a significant difference, and how do you see that going forward?
Yeah, a couple of areas. I think the most important one to me in a business context is that we, to a great extent, has removed, not entirely, and we shouldn't be entirely remove the data science out of it, but to a great extent we have taken the human out of the loop. So traditionally there had been this data collection, a lot of data analysis, then reporting and policy changes based on that, and it can be whether it's in finance or it's in retailing, but what has happened is that we close the loop without the human. So we optimize automatically, trying to understand which product sells the best, which products is a given user interested in, without having the human doing that analysis. So instead of having a weekly meeting where we decide something, it happens every second. And that feeds straight into, say, logistics, into planning, into ordering. That happens automatically based on user demand. So we start making predictions that are running in an automated fashion. And I think that's one of the biggest changes in the way that we do business with the impact of machine learning.
If we kind of dive into a very specific example, and I think most of us can relate to Uber, even though it's not allowed in Denmark. The challenge of knowing the price up front, knowing the duration for the drive and for the car to be arriving, how has that changed over time, and what role has AI played in that?
Oh, it's central to that. You can only make that price estimation up front if you have a strong prediction. If you have a high level of confidence. And to have a high level of confidence means that you have done this for a while, you have gathered tons of data, and you can make these very, very exact predictions that are mostly correct, and therefore you're not going to lose money.
Yeah.
And you can even start making those predictions around competition too, so you can actually adjust that price based on other circumstances than just what the raw cost of the trip is.
Yeah.
Overall, there are many examples of machine learning at Uber that is that's very generic in sense. I want to mention one particular one where at Uber we will basically track every single pickup for every single trip.
Yeah.
And by tracking millions of pickups every day, the system will learn, just like the character on the swing and the chicken, the system will learn to make a frictionless pickup.
Yeah.
So what happens in the Uber app since late last year, we launched the feature that if you request a vehicle, it will guide you to a frictionless pickup. So it'll ask you to walk, 15, 20 meters down to the corner where the pickup will be better.
Okay.
No human planned that.
Okay.
It's basically just users using the service millions of times that improves it.
Yeah.
So whether it's price estimation or frictionless sales, etc., that loop is so important.
It is. We have one here from Victor from Nordea. And actually there are multiple questions, but I think we'll start with one. We see so many startups currently having AI in their tagline. Do you think we are in an AI bubble?
I do think that we are in some kind of AI bubble, in the sense that yes, there are companies claiming they're doing AI when they in fact are not really doing AI.
Okay.
And we have to watch out for that.
Right.
However, I will counter that and say that we are seeing real results.
Yes.
That are dramatic in nature.
Right.
So we are in a bubble, but we are also in a paradigm shift at the same time.
Yeah.
And I have great trust that AI is going to change the way we do business.
Right.
It's already done it for the companies I worked in. But of course, we should be careful to not to throw that AI word around too much either.
How significant can the AI-based changes be for a company? Let's say you're with Unity now, and how is it changing the way Unity is working, developing? Is it mainly on the developer side, on the development, or is it on the selling more products? How is it impacting the business of Unity, would you say, going forward?
Yeah, it really impacts almost all elements of the business.
Okay.
Yeah? So I briefly mentioned that on the monetization side, basically using machine learning to understand your gaming behavior allows me to identify other games that I will have a very high confidence in that you're going to like as well.
Right.
So I can basically get you to play more games.
Right.
And you are just like sponsored links on Google, you're actually going to be happy because I'm going to find stuff that benefits you.
Right.
Yeah. So that is basically through machine learning.
Okay.
It's only if I learn from your behavior and learn from other people's behavior that I can basically understand what you like.
Okay.
Yeah? So that's just one example. I can get you to play more games and you will even be happy.
Okay.
Yeah? It's not something,
No.
vicious here trying to get you to waste more time. It's more enjoyment. Yeah?
Right.
But that's that part of the business.
Yeah.
Yeah. There's also game development.
Right.
There's a lot of programming taking place in game development. Many characters in games, the NPCs, the non-player characters, are in many cases hardwired. They're programmed in. They're refined. A lot of their behavior can be learned as well.
Right.
So we are going to come out with APIs that are going to allow game developers to more easily use things like deep reinforcement learning to program or train their characters.
Yeah.
Yeah.
So those characters will, in a way, have their own life.
Yeah.
based on all the time adjusting to whatever is happening in the game.
Yeah, and they will be able to learn from the human players. They will be able to learn from simulated data.
Fascinating. Really fascinating. I'm a big fan of Netflix.
Yeah.
And their search, not their search, but the search algorithm or the presentation of, and there's a long history of that development actually. As I remember, they started out improving it originally by making a competition and having external developers help them improve. And I think I heard you talk about the Netflix, how smart their recommendation engine has become in terms of using not only titles but pictures. And can you just shed some light on that?
Well, that's a really good question. Yeah, Netflix is an awesome example of what has happened.
Right.
Actually, the matrix that you see when you go to Netflix is actually a former office mate of mine at Amazon who now runs that. So what happened at Netflix was that it started out as what I would call traditional machine learning. They're very famous for the Netflix competition. They built a fantastic, they got help from the outside through putting up $1 million reward. And they built a superb recommendation algorithm that's basically based on what movies I watch, what movies people like me they watch, and I haven't watched those yet, and they become recommendations. But what has happened over the years at Netflix is that the recommendations have sort of shifted. It has become more important for Netflix that you watch their TV shows rather than you get movie recommendations, I say. So what they're doing now is that they are using, they basically have multiple images per poster images per movie or TV show. They have different actors in those, and they learn over time what makes you click on a TV show. So it's less about recommendation now and more about finding ways to get you to start watching the TV shows they produce.
So they might even use different pictures of different characters depending on your profile. So it might be in my case, maybe the female lead as opposed to, I don't know, the male lead, because I might be triggering more on that. So
they may have 10, 20 different images for a given TV show or movie with different actors in, and they will know, they will find out over time which actor make you click. They also have different color schemes. And you can imagine how, blue, green, red, different color schemes that may attract different people. So they customize it for each viewer. So they move in a business world. We definitely are moving away from segments and segmentation of the customer base into what we call the cohort of one. So every customer gets a unique treatment.
So it's really about the individual customer being offered a very tailor-made proposition.
And in Netflix, that leads to you looking at a lot of TV shows and finding a great enjoyment in watching these shows. At Amazon, it makes you shop around more efficiently. The problem that we have seen is that at Facebook, it makes you watch more news that you agree with. So
more polarization.
Which I must admit I would never have predicted that. But I can see how that happens now. That basically you just get more and more of what you like. So you never see the opposing views.
Let's move into a little bit about organizations and how they can use AI, and actually I think how they can get started. I think we have a unique opportunity because you've actually built this capability within many prestigious companies. So if you are either large company, startup, how do you get started? Because it's not yet so common in most companies to have a strong AI capability.
So number one, there are plenty of cloud services out there, whether it's Google, Google Cloud Platform, GCP, or it's Microsoft Azure, or it's Amazon Web Services, for example. Those three all have machine learning services. Yeah, so there's no excuse.
No.
Yeah, there's lots of training and help to get started on that. And in Denmark, there are companies that can help out, getting started as well.
Right.
And then it's really a matter of picking what we in Silicon Valley always call the low-hanging fruit.
Yeah.
So it's take core business problems that are not overly complex.
Okay.
Business problems where you have data.
Right.
That you can bootstrap with.
Right.
So I want to give the example of an online shoe company selling shoes with free return. Their business problem is a lot of returns.
Right.
People buy 2 or 3 pairs of shoes because they buy different sizes. They keep the one that fits and return the other ones. Yeah?
Right.
That piece of data, the returns, is actually putting me in a position to use machine learning to start making 2 kinds of predictions. Number one, I can make predictions around the shoe size of a customer.
Right.
And I can make predictions around how brands, different brands they run, small, normal, or large. Yeah? And this is a real example that comes from Amazon. Yeah, you could actually use that data to improve your business.
Okay.
And it was not a big, complicated thing.
No.
We had the data,
Right.
we had the will to do it,
Yeah.
and a handful of engineers to implement it using the cloud service.
Okay. And because as I've understood your role, it's often been building the platform actually. But you're saying that to start, you don't necessarily need to build the platform. You can tap into the cloud-based services.
Yeah, and I strongly recommend that. Building the platforms, it requires a lot of very specialized people.
Right.
And it's sort of, I prefer to stay focused on the problem at hand.
What about the data? Because it's not always just easily accessible, tagged, etc. The data.
Yeah.
So is that where the main challenge is for most companies to start?
I think so. I think it's very important to establish what I would, the term we use is data lake, or some kind of repository of company data where I can retrieve it from.
Okay.
It is often by mixing data from different sources that we achieve the most progress in making these predictions. Yeah. So it may be data from a purchasing department. It may be data from shipping. It may be data from finance that comes together and create value.
Victor is asking, where do you see opportunities in the FinTech space or in the generic startup space? Are there areas that are particularly interesting, in your opinion, to kind of pursue?
Yeah, the areas that we need to look at first is the areas where we do have rich data.
Okay.
And that's sort of the tricky part of AI and startups and business opportunities, is that without data, there's nothing to train from. So it's actually much less about the algorithms and much more about the data now. Yeah. So I would say in previous times, a company could establish a business based on some algorithmic thought. They have some ideas, they have some bright people who implement those ideas, and they have a business. Yeah. Nowadays it gets a little tricky, and I mentioned how is Uber able to make price predictions? Well, because they have tons and tons of data, have millions of trips they do it from. If you're a new entrant in that space, you can't do that. No. You don't have that data. Yeah? So it's really about the data. And therefore, it's if you look at the FinTech space, I want to give some examples where, for instance, if you want to give instant credit, you have to go out and look at alternative data sources. So it may not just be your history of loans and payments and bank accounts. It may also be using information around things like your behavior, if you are one of these people who get up in the morning, go to the gym, go to work, go shopping, and go home, you have sort of a very regular lifestyle.
Right.
It's purely based on your travel behavior.
Right.
That may be a stronger indication of your credit worthiness than, say, your zip code. So you have to go out and get these alternative data sets to improve your business.
Yeah. And then you get into the discussion we had earlier about explaining, and I mean this is a very interesting area, because you might have to explain the rejection of a loan, which you can't necessarily do based on your driving behavior.
But there are examples of companies that provide, say, instant credit. Yeah. And they can provide instant credit and make money because they're better at rating you than their competition. Yeah. And in some cases, I know that they're using things like data from the mobile operators. Okay. So basically, based on your phone number, they know what kind of person you are.
So in terms of large companies and opportunities, would they how do you get started? Because we talk about data, we talk about AI, and many companies, they come from a different world where data has not been the core of their value. And we're talking about data now being center stage in terms of value creation. Yeah. So it seems kind of how to get started. Are you focusing on the back end? Are you focusing on your consumer-facing type of applications? Do you have any kind of guidance if you want to kind of step your toes into this water here?
Yeah, I think it's number one, you have to keep an open mind. Yeah. And you have to stop saying, well, we normally don't do this or we normally don't do that. Right. It is really about gathering the data. Okay. There are many companies that are not data-driven or data-based. Fortunately, I worked in companies like Amazon and Uber. They are all data-driven. Yes. Unity, we have almost a billion monthly active users, is all data-driven. Yes. But a lot of companies, I have noticed, for instance, do not gather data from their web front end. Yeah, and it's very important if you're a bank and you have a bunch of services on your web page, the ordering of those services need to be driven by customers. Yeah? Right. The most important first. Yeah. So whatever people see on that web page and they click on, and whatever they see and don't click on, those are very important events that needs to be collected. Yeah. Right. And a lot of companies are ignoring that.
Right. Just in terms of getting started, because one of the challenges for many companies is that they don't have the competence inside. They don't have the possibility of necessarily hiring or building a complete function with AI and machine learning. So what do you recommend? Do you get started working with external companies? Do you build the competence? How have you seen this kind of?
I think it's a mixture. Okay. I think that because there are cloud services available out there, you can start having your own internal team start looking and understanding that. But I think also you need to pull in external help to sort of bootstrap you and get you going faster. Yeah. And there are companies in Denmark doing that. I'm working with a couple of companies in Denmark doing that, and it's basically a mixture of building that competence internally in your company and getting some help to get it go faster. Yeah.
And do you need some type of critical mass in terms of employees in a function, or is it just one person, or do you need to have 10?
I think it's more about getting the commitment from the business side to actually do this. I think it's about getting the commitment.
Okay. Yeah. This is Mads asking, I think this is a key question about attracting talent. What to look for when building a data science team? How do you attract talent in this space here?
Yeah. I have a very strong opinion about this.
Okay.
What I'm looking for always is a core software engineering skills.
Right.
So there's a lot of thinking that machine learning is about producing some nice graphs and presentations, To me, machine learning is about integration into the IT systems. So I'm looking for machine learning from people with a machine learning background, and there are plenty of those actually. Not that many, but they exist. Yeah? But I'm looking for that basic software engineering skill that allow them to implement their machine learning skills in a context. Because it's only when it gets integrated into our IT infrastructure that it's going to improve business.
And any recommendation about how to become attractive for these talents to join a company?
I think you have to put out a very clear message that you are committed to getting into machine learning and AI for your business. You have to commit to that and make it very clear to attract people to work in this space.
So I think this is a key message for companies. Then you mentioned it before also, that there needs to be this commitment from the management of some sort, that this is part of our strategy, this is important, we're going to continue doing it, and it is going to be a core in our business.
And pick those business pick some low-hanging fruit, pick some business examples where you can actually execute on it and have some demonstrable results.
So rather start small, proving your success, and then not start with a huge, massive big data problem. Okay, so I just want to ask you a little bit about on your own background. If you were yourself, this is kind of a question, if you were to launch something yourself, are there any specific ideas that you have where you see, we've been around it a little bit before, where is the most obvious startup opportunity in this space?
I'm very fascinated about the robotics space. Robotics is we're coming to a point. Robotics include drones, etc. I think it's very fascinating. People talk a lot about IoT, the Internet of Things, and I want to make sure that everybody understands those things do not have to be electronic. If you have drones, you have robots, every single plant in a field would be a thing. You know exactly which seed you put in the ground, where you follow that plant, you make sure that that plant gets, you know, the fertilizers, the water, everything. All that is really relying on robots, on drones, on autonomy. I think that is just an area of boundless interest. I do want to mention specifically in FinTech, there's another area which is to use very, very broad and very large amounts of data to improve things like trading. We see a lot of progress in that area. I'm very fascinated by pulling in thousands of resources to make decisions.
Okay, I think, Danny, we're getting towards the end, and I think we could have gone. We could have continued, but we need to round it off. This has been really great, Danny. Thanks for showing up so early. Thank you very much, and we'll see you next time with Danny from Stanford.
Thank you for having me. It was fun.
Thank you, Danny.
Thank you.
Okay, bye.